So in this problem, it says for a series of measurements with values of 10, 10, 12, 13, 14, 15, 16, what is the mean, median, and mode? Mean, if you recall, is the addition of all these numbers divided by the total number that of individuals. So there's a total of 1, 2, 3, 4, 5, 6, 7 numbers, and the addition of all. So we are going to add these up. So we got 20 plus 12 plus 13 plus 14 plus 15 plus 16. So we got 90 over 7, which is 12.86. So that is the mean. The median is the number that's right in the middle. So if this is an odd number, then obviously, as you can see, there's 3 to the left, 3 to the right. So over here, the 13 is the median. But in the case that it is an even number, so let's say this 10 wasn't there and there's only 6, the 13 and 14 are what's in the middle. So what you would do is you just add the 2 and then divide it by 2. And that's how you get the median for an even number. And the mode is so the value that occurs with the greatest frequency, which in this here 10 occurs twice, so the mode is 10. So in this problem, it asks you what is the probability that no people in a group of 5 have the same birthday. So it says that don't. So what this problem is really asking you is to find the probability that all 5 individuals have distinct birthdays. So they are not the same birthday. And this is really easy to set up. So there's a total of 5 people. As you know, there's 365 days in a year. So how you would just set this up. So in this case, the first person, since we're starting out the probability, first person is going to be 365 out of 365, and then you multiply that. The next person, since this person is taking up 1 of the 365, this next person, you just subtract 1 from 365, so it would be 364. And now you're on to the third person, so you subtract 2, so then it would just be 363, and so on. And you do this for the number of people, so you do this 362 and 361 out of 365. And then you multiply this out and you get 0.97. So in this problem, you're given a list of data and it is said that the mean of them is 8.625. So you recall the mean would just be the addition of all of these numbers divided by how many there are. So there's a total of 8. So whatever the addition is divided by 8 gets you 8.625. And it's asking us to find the standard deviation. If you look on page 42 of the reference cheat sheet that you'll be given, you'll see that the standard deviation is just going to be 1 square root of 1 divided by n with the summation of xi minus u squared. And over here, this will be your x bar, so it will be your mean value. So 1 divided by n is the total number of data that's given to us, and there's a total of 8, so it's just 1 over 8, and the summation, our xi, is going to be each individual number here. So the first one would be, so over here we label xi as 2, 4, 6, 8, 10, 12, 12, and 15. So what we do is we do this part for each one of these. So when we go ahead and we do this, so this is xi minus X bar, and X bar here is our mean value squared. So pretty much how you get this is going to be 1/8 times, so we start out with 2 minus 8.625 squared plus, into the summation, then we go to the next number, minus 8.625 squared plus 6 minus 8.25 squared, and we do that all the way till the last number, so 15 minus 8.625 squared. When you go ahead and you multiply this out, you will get 1/8 times 137.875, and then this is just, when you multiply this out, 17.234375, and when you take the square root of that, our final answer is 4.15. So that is our standard deviation. Now, if you're given the same information and asked to find the sample standard deviation, the equation for that is essentially this, except right here is just 1 divided by n minus 1. And then your summation would start out at for n, and then n equals 1 here, and you go ahead and you do the same thing for here. You plug and chug everything, and for a sample standard deviation, you would get a different answer, because over here it would be, in this case right here, since there's a total of 8, it would be 1 divided by 7 times all these numbers. So this next question says test scores for a class followed a normal distribution, and the distribution follows the density function shown below. So this is what it looks like, and it's given a mean value of 78%, a standard deviation of 8.5, and it's asking us where would that 90% appear on this graph. Now, so our mean is 78, which means this is our 78% mark, and standard deviation of 8.5, and it's asking where would the 90 on this graph, which shaded region would it be. So what you do is you do a z-score, and for 90% it would just be 90, what you're looking for, minus and divided by the standard deviation. So you go ahead and you do this, you get 12 over 8.5, which is 1.412. So once you get this, how you set up this graph is this would be 0, your 1, your 2, minus 1, minus 2. So 1.4 will roughly be right there. And then what you do next is you take the standard deviation. So we know this is 78. And what you do is you just subtract 8.5 per over here. So if we do 78 minus 8.5, so this would be like 69.5. Then you do minus 8.5, and you get 61. You add 8.5, 86.5, and then you add another 8.5, and you get 95. And we need the 90%, so from 86 to 95, so it will be like 90% will be somewhere right there. So you can get an estimate of roughly where it would be. In this next problem, we have a group with a sample size of 8, they have a standard deviation of 9.5 and a sample standard deviation of 10.2, and it's asking us for the standard variance and the sample variance. So for the standard variance, it's very easy. It's just square root of the standard deviation, which here we're given 9.5. You just square that and you get 90.25. And then for the sample variance, we use the sample standard deviation 10.2. So it is just that squared. And for that, you calculate it to be 104.04. So this problem says, suppose that the length of a telephone call from a normal distribution with a mean length of 8 minutes and a standard deviation of 2.5 minutes. And it's saying that the probability that a call selected at random is greater than 15.5 minutes. It's saying what is the probability that selecting a random call and it is greater than 15.5 minutes. You can find this on page 51, the reference, and what you got to do for here is the z again. So this is what we're looking for, and you subtract it by the mean, the 8, you divide this by the standard deviation, and you'll see that you'll get a value of 3. This is your x value. Now with this, you look at the normal distribution chart in the reference, which is also given, and you'll see under Rx, if you follow the table, you're going to follow it to 3, and then you move along Rx, and you will see that the value given is 0.0013. So in this problem, it says that there is 100 balls in a bag, each numbered from 1 through 100, and it's asking us one ball is drawn at random, and what is the probability that the selected ball will be odd numbered or greater than 80. So this, you can find this in your reference as well under law of total probability, and it is the probability that each so this one, so the law of total probability states probability that event A or B occur, and that is the event A occurring or event B occurring minus event A and B occurring together. So here our A is going to be, so our first condition, it's odd number, ball is odd, and from 1 through 100, the ball being odd, there's 50 numbers that are odd from 1 through 100, so it is 50 divided by the total number of balls, so this is just 0.5. Event B, which is greater than, so the ball is greater than 80, and from 80 through 100, that's just 20 over 100. So this is going to be 0.2. And now we just go ahead and we plug in these numbers for this right here. So P A plus B equals probability that A occurs by itself. So 0.5 plus B occurs, 0.2 minus, and now the multiplication of both of those, you get a final answer of 0.6. So in this problem, it says, what is the probability that either exactly 2 heads or exactly 3 heads will be thrown if 7 fair coins are tossed at the same time? So first, what you do is you figure out the total outcomes in this scenario. So you see that a coin has a head or tail, so it only has 2 outcomes. So it would be 2, and since there's 7 coin tosses, at the same time, it's 2 to the 7th, which is 128. You'll need that number later on. So we're going to go ahead and label these as first and second. So our first case, exactly 2 heads. You look in your reference and you will see that C n comma r is n factorial divided by r factorial n minus r factorial. Here our n is the total number of coins, 7. Our r is going to be the 2 outcomes, which is just 2. And then we go ahead and we do 7 minus 2 factorial. And we get an answer of 21. Now factorial, you just go under probability and it's number 3 here. Factorial, if you don't recall, 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. But in the calculator, you just click on probability and it's number 3. So we get an answer of 21 for that. And in this case, since 2 heads out of 7 coins, the probability of event A would be the probability of 2 heads, and it is this number divided by the total outcomes, which is 0.164. Now we go ahead and we do the second for exactly 3 heads. Same thing. We have 7 coins. We have 2 outcomes, heads or tails, and 7. And in here, it's minus 3. We get an answer of 35. So now exactly 3 heads would be 35 over the 128, which is 0.273. And now from the law of total probability, so now we're trying to find the probability that either of these occur, which is, so total probability, as we did in the previous problem, is event A occurring plus event B occurring minus probability of event A and B occurring. But in this specific problem, since the 2 are mutually exclusive, because it's asking us 2 heads or exactly 3 heads, and it's saying that 7 coins tossed at the same time. So these 2 are mutually exclusive. So this right here will just be 0. So you're going to plug in this number and this number, and you add them together, 0.437. This next problem says that 4 fair coins are tossed at the same time, and it's asking us what is the probability of obtaining 3 heads and 1 tail. So here we're just going to look in our reference and use the binomial probability. And so we set our variables. So P is going to be the probability of heads, which in this case is, since a coin only has heads or tails, it's just 50-50, so 0.5. Our Q will be the probability of not head, which is just so each side is half, so it's 1, and not being heads would be 0.5. So again, 0.5. Now n is it going to be the number of trials, which in this case, since there's 4 coins, it's 4. And then our x is going to be the number of successes. In this case, we're counting the heads to be successes. So this specific trial, 3 heads, and we go ahead and we set it up. So it's n factorial over x factorial n minus x factorial times p to the x times q n minus x. And here it's just 4 factorial n, so you just plug and chug. So most of these problems are just going to be plug and chug for the first half. 0.53, then 0.54 minus 3. So your final answer will be 0.25 times 1/4. It's given in this, or you just multiply it out. We're going to finish it with this last problem, which asks us, you have a fair coin that you toss 10 times, so 10 separate times, and what is the probability that you get exactly 5 heads in 10 coin tosses? So here again, we're going to use the previous binomial. So in this one, we are going to use binomial distribution. So again, we set our variables p, so the chances of heads, which is just 1/2, since it's head or tail. Our q, which is so not heads, and again 1 minus 1/2, so 0.5 here. Your n, which is number of trials, 10 coin tosses, 10. Then our x, number of successes, so number of heads here, which exactly 5 heads, 5. So then we just go ahead and we solve it. So we're looking for 5 heads, so it's going to be 10 factorial over 4 factorial, 10 minus 5 factorial, 0.5 to the 5th, so the number of heads, and then 0.5, 10 minus 5. And here you'll see that it is 10 factorial, 4 factorial, 5 factorial. Since these are the same, you just add the powers. 10. So there's 5 factorial, 10 there. So the first 5 could be canceled out. So 1 factorial, 2 factorial, 3, 4, 5 factorial can be canceled out from the top, and you cross it out with this. So what will be left is 10 times 9 times 8 times 7 times 6. So the last 5 are left. On the bottom you have 4 times 3 times 2 times 1 multiplied by 0.5 to the 10th. And you do the multiplication and you get a final answer of 1.2305.